This is Mr. Priscilla picking up after the break, discussing lower sines and lower cosines. And I want to do a couple more solving triangle problems where we have to decide which rules are we going to use and go through them. So, problem right here. It says solve the triangle. And by solve the triangle, it means find side B, find angle A, and angle C. Find everything that's unknown. And this has, we're told side A is 4.31, side C is 5.58 meters, and angle B is 29.4 degrees. I always got to draw the triangle. Sometimes I see all these students doing it and they don't have a triangle drawn anywhere, but I always feel the need to draw a triangle. ABC. Angle B is 29.4 degrees. Side A, 4.31 meters. And side C, 5.58 meters. This is going to be the law of, let's see, sines or cosines? Well, the law of cosines. Use the law of sines if you know or can easily find all three angles. You need to know at least two angles right off to use the law of sines. Here, no. So we're going to use the law of cosines, and we're trying to solve for side B. So that's A squared plus C squared. It's the other two sides. The 4.31 and the 5.58, minus 2 times those other two sides. Cosine, the last thing you write is the first one, B. So B squared is 4.31 squared plus 5.58 squared minus 2 times each of those. Cosine B. Can y'all see that? Now we'll have to punch all of that into our calculator and then take a square root. Okay. Oh, this looks a little lopsided, doesn't it? Okay. Let's see if I can get this showing in my calculator. Would be 4.31 squared. Wait, let me clear out all of it. 4.31 squared plus 5.58 squared minus 2 times 4.31 times 5.58 cosine 29.4. Close parentheses, enter, and that's B squared, so second square root, second A and S, so B, it says round to 4 decimal places, so B is 2.79418,399, rounding to 4 decimal places, 1, 2, 3, 4, 2.7942. Oops. So that gets us side B. Yeah, round to 4 decimals. 2.7942. Now we're told, okay, find angle A. Well, using law of cosines. Cosine A. Now what's the pattern? It's the other two sides. B squared plus C squared minus this one all over 2BC. So it's those two sides that you were given. No, it isn't. It's B. Here's B. I hope I didn't mess up on that one, as if I did. So B squared plus C squared, 5.58 squared, minus A squared, 4.31, all over 2 times 7.942 times 5.58. Now when you punch this in your calculator, I think you have less difficulty if you use as few parentheses as possible. Like you could put each one of these numbers in parentheses, but don't. Just put the top in parentheses and the bottom in parentheses. Let's see what it'll look like. If I say clear all of that, parentheses, parentheses, 2.7942 squared plus 5.58 squared minus 4.31 squared, and then close the parentheses. If I can give you any advice, only use one set of parentheses here and one there. Divided by use another set of parentheses, but only one. Parentheses, 2 times 7.942 times 5.58. Close the parentheses. Ooh. Enter. And that gives you the value for cosine A. To get A, you go inverse cosine. So second cosine, that gets to go cosine with the minus 1. Second A and S. And let's see. Yeah. 76.714666. 76.714666 dot dot dot. That's the answer for angle A. How are we told to round it? Round it to the nearest tenth. So angle A would be 76.7 degrees. And almost finished here. To find angle C, you don't need to use any trigonometry. Just use a little fact from geometry. The three angles should add together to give 180 degrees. So 180 degrees minus 76.7 degrees minus 29.4 degrees. So, oops, I'm dropping my calculator. 180 minus 76.7 minus 29.4. That's going to be a 73.9 degrees. Okay. This is solving a triangle using the law of cosines. Okay. Now, never when you're doing this do you decide to start using the Pythagorean theorem. Sometimes students will pop that out, but no, use the Pythagorean theorem when you're solving right triangles. Oh, we don't have right triangles here. Let's do another one. How about this one here? We're told, determine the remaining sides and angles. I guess I got carried away with this assignment, didn't I? Determine the remaining sides and angles. Well, here we know two angles right off. We can easily find that third angle by subtracting from 180 degrees, and therefore this is going to be a law of sines problem. 180 minus 30.73 minus 22.12, that's going to be 127.15 degrees. Now we need to know side A and side B. Well, let me first draw the triangle. Again, I always want to draw the triangle. Sometimes students say, oh, I don't want to draw that triangle. Angle A is 30.73 degrees. Angle B, 22.12 degrees. Ooh, it's getting hard to see or to read. And my angle C is what we have right up there, 127.15 degrees. We're told that side C is 13.09 meters. We're told to find side A and side B. So, to find side A, I'll go A. Now this is law of sines, because we know all three angles real easily. A over sine A equals B over sine B. Well, we don't know angle B, side B already, so now it's going to have to be C over sine C. 13.09 over sine 127.15 degrees. So lowercase a, 13.09 sine 30.73 degrees divided by sine 127.15 degrees. I won't torture you with the calculator. Let me just punch it in real fast. 13.09 sine 30.73. Be sure you close those parentheses. Maybe I will show the calculator. Notice how I close the parentheses around this 30.73. Then divided by sine 127.15 degrees. Enter. And we're getting 8.39199. We're told to round this to the nearest hundredth. So 8.3, we leave it as 8.39, not make it 8.40. Okay, so 8.39. And now find side B. This is for students, oh, they use the Pythagorean theorem. And no, 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 you can't use the Pythagorean theorem. Okay. Why? Because it's not a right triangle. So to find side B, I'm going to set it up the same way. B over, ooh, I'm running out of room, sine sine B, angle B is the 22.12 degrees, equals, and I'll just stick with the 13.09 over sine 127.15 degrees. So multiply, so here's where I'm going to punch in 13.09 sine 22.12 degrees divided by sine 127.15 degrees. 13.09 sine 22.12, close parentheses, divided by sine 127.15, 6.18400,875. Another one, round to the nearest hundredth, tenths, hundredths. So that's going to be a 6.18. Well, I hope that helps you, together with my long lecture over the law of sines and cosines. This was just a couple more examples I wanted to do of it. And let me see. There it is. So this does it for law of sines and law of cosines. We're really out of time now, so I'll let you go. Work on this stuff. Bye-bye.